In this video, I'll tell you what some of the critiques are about p-values. So not everyone loves p-values, and I'll include myself in that group. So some of this is my opinion, but this is also modern conversation that has been happening within the last few years. So these aren't in the books, and some of these are a little bit more philosophical, so maybe not so appropriate for a statistics textbook. The first critique is that taking an arbitrary threshold for a p-value for significance, so often the case, historically it's been the case that p less than 0.05, this is considered significant, and anything larger is considered not significant, just noise. So for this academic publishing world, and all these biology journals and ecology, all the social sciences, often it's been the case that reviewers for research will not accept manuscripts that have p-values anything greater than this. So if you have a p-value of 0.1 of your data, then they just don't accept it. They consider it a negative result. That is not being able to show anything, but it's still a result. So what this means is that the only papers that come through are the ones that show they're statistically significant. And because the threshold is 0.05, this means that even if the null hypothesis were false, 5% of the time you're going to get a significant p-value, even if the null hypothesis is false. So this is where publication bias comes in. So you're only seeing those experiments that can show they have a successful p-value. The other danger with this is that researchers needing to get published, they will occasionally, and knowing that they need a significant p-value, they'll occasionally do things like delete the largest number that was an outlier. Say, oh, it was an outlier, it's not really realistic. And they make this argument to themselves or to the reviewers or anyway, and they delete it, exclude it from their data, and then something that was not significant can become significant in this way by editing your data, which, as a statistician, we hate this. We hate it when people do these kinds of things because then we lose a picture of what's actually happening. So in general, I think personally that this can lead to bad science. So if you think about the thing about the vaccines causing autism, this is an example of bad science, right? P-values or fake data, and it leads to people believing something that's not actually true. So this is not the goal of science at all. Another critique is that the p-values, they boil everything down to just one number. So it's really simple, and that can be nice, but they're so easy to misinterpret. The problem is, and I won't tell you what all the misinterpretations are because I don't want you to hear them and think they're the real thing, but you can read more about them in your book in section 6.2. So because they're simplistic, they miss a lot of nuance that you can otherwise do with the analysis and with the data. And they often don't. So they do exactly what they're supposed to do. And nothing more, nothing less. That is, p-values, the probability of seeing data that extreme under the null hypothesis. That's all they do. So they can provide evidence against the null hypothesis, and that's it. But there's a lot other more interesting questions that you can ask that don't necessarily require a p-value.